Welcome to 2018 cost report trading for Formula SAE Australasia. So something that we'll do, give a quick spiel about ourselves. And why do I have that you've been in cost judge from 2015 onwards? David Ford from SAE Australasia and previously from Ford Motor Company is actually a cost judge from well and truly before 2015. He's I think your first competition was 2004, something like that. Yeah. 2003, yeah. And a lot of the part and parcel parts within Auscomp as well as the cost event, thanks to David. So definitely a veteran within the organising committee and the judge team. My name is Norbert. I am at Curtin University, currently a sessional academic there. I have been a part of the motorsport team in the past prior to joining Formula SAE as a judge. So I actually got thrown into the deep end coordinating the cost report in 2013 and 14, having been on the team for barely a year and not really having much exposure to the way that things were manufactured. So based on my learning experiences as well as some of the others, we're hoping to actually pass on some of the information that we've been able to get ourselves. Now, one of the other people who has been able to contribute in years past is Mario Coppola, who isn't able to join us today. Mario and I actually created majority of this presentation over the past couple of years and been updating it. Mario also had served as the cost report coordinator for Swinburne University in 2010 and 2011. So we'll also acknowledge the work that Bill Riley and Michael Royce from the SAE Detroit section over in the United States have done. They've actually created a number of examples that we're going to be showing a little bit later today, and some of the baseline, I guess you could say, strategies that teams are able to use so that their cost reports are going to be effective come competition time. So this is basically what we're going to be covering, a little bit of an introduction into the cost report. We'll give a general overview to begin with, what kind of resources can actually be used to generate the cost reports, where materials can actually be found within the list, as well as where the published lists are actually located. After that, I'll hand you over to David, who will look into the cost report essentials, the report itself, where everything is getting published, how the templates are getting used, and the cost tables themselves as well. Now, the cost tables as well, we'll have to delve into that a little bit further, given that there is a change within, I guess you could say, the international way that the cost report will be getting run. But for any competitors who have attended 2017 events, the 2018 event at Formula SAE Australasia will be run in basically an identical fashion. The next section that we'll cover is with regards to the, I guess, the way that you are able to choose how to report particular items. And we want to clarify a couple of things with regards to making parts versus buying already complete parts. And for any parts that you may have purchased, which don't actually exist in the cost table, there is something called an add item request, and we'll give you the information as to how this can be used. Then we'll actually, rather than just say this is enough, we'll give a step-by-step example of an ARM case study showing how part manufacture is actually done, how parts and tooling and final assembly can actually be done within a cost report. Next section that we'll cover is at the competition. So what is required from competitors, say for example, if things have changed between the time that they've submitted the cost report and the time when competition begins, if there's been any modifications to the car. This does need to be reflected within the cost report, and the addenda will actually explain the method that we'd like you to use. The next section will actually talk about what actually will happen at cost events. So the overall judging process, what you can expect from introductions to the judges, how you'd actually be able to present your vehicle at the beginning, and yeah, the judging method that we actually use come cost come the cost report at the actual Formula SAE event later this year. So what will be expected from the visual inspection, and if there are small little changes within the visual or if there are small little errors or things that don't quite line up between the cost report and the car we see in front of us, how those penalties will be applied. And finally, we talk a little bit about the real case scenario, not just about what can actually be expected, but also explain why it's not just a 20-point event which is worth writing off, and more so why it's practical for the sake of, I guess, your future as engineers in industry. Once that's been done, we'll conclude with some general do's and don'ts, and yeah, open the floor up to any questions. So without further ado, this is what you can actually expect with regards to the general overview. We all know what Formula SAE is. It's an automotive theme engineering design competition, and it's really there to be able to prepare student engineers for the real world rather than waiting for you to get thrown into the deep end once you graduate. So the specific points that Cost Event wants to bring to the forefront is that cost and budgeting are critical to the real world. As much as blue sky engineering is a lot of fun, the money does need to come from somewhere. On top of that as well, it's not just making sure that the costing and the budgeting are in the process, but making sure that the organizing that information to actually help the decision-making process is also necessary. Oh, we've got a few more visitors. Where's our chat? Okay. Shift that to one side. And participants will put up there. All right, so once we recognize this, we also have, once the decision making process has begun, we have to realize that there will be some to and fro in the decision making, and cost needs to actually be made within the, play a role within that process. And again, once all these decisions have been made, they need to be explained as to how you've been able to come to these decisions. Now, in regards to cost affects not just an engineering department within a project, but you'll have marketing, finance, administration. So you will have to explain these decisions with respect to cost to other people who may not have an engineering background. So this is why we feel that Cost Event is especially effective. Now, how is Cost Event structured within the competition? This is how it goes down. So 100 points of the 1,000 is on offer cost event. Now, 80 of those points come from the cost report itself, and 20 from the real case scenario, which will actually be announced a little bit later in the year. And you'll have a little bit of time prior to competition to get your case ready. Now, with the cost report, half of the points on offer for the 80 will come from the vehicle's cost itself. So the cheaper that you're able to design and manufacture your vehicle, the more points you'll receive. But rather than just making it cheap, it needs to be reported on accurately. And this is where the other 40 points for the cost report comes through. Now, in order to standardize everything across all teams and worldwide, there are baseline rules, cost tables, and part and assembly templates that are common to all the competitions. So especially for our international competitors, I know that we've got a couple within our group tonight, you're able to actually use exactly the same templates as what you've actually been using before. Now, with the Australasian competition, there will be some specific add-ons which are available at that website, that particular URL. If you go to SAE Australasia, the Formula SAE section, that's where it goes to. And yeah, the engineering design is all about the trade-off analysis, and making sure that the cost is a part of that analysis is definitely going to make your life considerably easier. Right, so in addition to those particular resources, we are able to find some templates and some rules at this website here, which is the SAE International Formula section. So if even if you don't remember this URL explicitly, just going to fsaonline.com, they will have a formula link there. Now, the important ones are the cost event section within the Formula SAE rules, and that's page number 132 in the 2017-18 rule set. There are standard tables as well, which we'll get into in a little bit. Templates as well, so the generic blank template for both parts and assemblies. Appendices are now actually located within the rules towards the end. And last but not least, there's some forms as well, for example, things like add item requests and such. Yes, we've got a question. Or somebody's talking.
It's a sneeze.
It might be a sneeze. We've got a Galaxy J5 Prime. I have no idea who that is. And we've also got a couple more visitors. Welcome. Right. So with regards to the standard tables, these published cost materials. Hello? Somebody's got a bit of a... what I'll ask is, if people aren't going to be speaking, would you please be able to mute the microphone? That way we'll be able to have any feedback there. All right, there we go. Right, so there will be lists of published materials made available. So the first of these is the standard tables. This will cover the materials that get used to manufacture parts, any sort of processes or process multipliers that are actually necessary to turn those materials into the parts used on the race car, fasteners used to hold it all together, and any sort of tooling that is required to make to perform those processes. The add item request, like I said, exists for purchasable parts that don't exist within the standard cost tables as of yet. Oh, we've got somebody scribbling on the screen for some odd reason. Okay. Moving forward, the templates as well. We've got assemblies and parts. So the entire car is made up of systems. Systems are made up of various assemblies within that particular area, and parts are used to construct the assemblies. We'll go through the methodology a little bit later, and then we've got the five appendices. So these cover the cost models and the methodology. A standard part numbering system, you are able to use your own one. We'll delve into that a little bit later too. The systems and assembly list for internal combustion engine cars. And another system assembly list for EV cars is actually made available through SAE Australasia. So that will be within the FSA rules download section. And then finally, when you're actually making the car and you're trying to fit it all together, there's particular methods of making sure that everything goes together. So if you're using power tools to tighten things and actually fit things, you need to make sure that you're able to fit those tools into the area. And this is where your power tool package envelopes come in. So we'll talk about that a little bit later on as well. Now, before we dive in, any further questions about that, or we'll be able to jump straight into the essentials? Feel free to put this down into the group chat if you like. No takers? Cool, let's move forward. So without further ado, I'll hand you over to David.
Right, good evening, everybody. I just clarify one other point. This PowerPoint presentation will be subsequently available on the SAE Australasia website. So therefore, some of the specific references and details in it, you can look up later and don't need to worry about getting all the details of them during this actual presentation now. We're now looking at the structure of how to put your cost report together. These may seem very simple, but they're very critical to how easy it is to see and manipulate the cost report by the judges. Generally, it takes anywhere from 3 to 5 hours to go through a cost report and do a decent judging and analysis job on it. Therefore, ease of use of the data within the cost report and able to pull different sheets out to cross-reference them and work with them is facilitated hugely by using a 3 or 4 ring binder, not a 2 ring binder. Invariably, they break apart, the sheets fall out, and they're not easy to use. Therefore, we want either a 3 or a 4 ring binder. We don't like a bound binder with a spiral type of fitting on it, or a fully bound as we've had in some years. This is like trying to read a Bible and then cross-refer between the New Testament and the Old Testament, and it's rather difficult.
Can I quickly jump in with that one as well? I'm going to weigh in on this as well, because me as a cost report coordinator, I got caught out by this in 2014. Now, we're telling each of you, I'm assuming that everybody within this meeting is a cost report coordinator for their team. Yeah, stick to your guns with this one. If you do have people within your Formula SAE team saying, oh, a binder doesn't look particularly professional if it's just a ring binder, just spiral binder, it will look so much more effective, or turn it into some sort of bound volume. Don't do that. So stick to your guns. Make sure that you actually use the ring binders. It's all of the things that I mentioned in this particular section are easy points. So if you get this part right, then you're actually making life considerably easier for you come competition. Another thing that's also particularly important about the ring binders, another thing that's especially important about the ring binders is that at times, if you do have the amendments that you would actually like to add to the cost report, say things have changed come competition day or even before, this way we're able to actually remove the existing sheet and replace it with the new one simply by opening up the binder at the right section, taking out the old sheet and putting the new one in. You don't have that luxury with a comb or a spiral binder, and it really does make life considerably harder for the judges. So please use the ring binders, and don't let anybody else in the team convince you that you need to use something other than a ring binder.
But the next point here are the ones where, in fact, you create how professional and good engineering layout your cost report is, rather than in the binder format. Tabs for each system, very clearly labelled, durable tabs, which will stay there after being flicked through a number of times. One for each system. Some teams even include sub-tabulation as well behind each of the systems. That can be an advantage if done with a certain amount of discretion. Adding a tab, a sub-tab for every single part in the car isn't really a good idea, as some teams have done. You end up with a binder that's twice as thick as it needs to be, and the extra tabs only get in the way as waste sheets. So the key thing here is definitely have clearly identified tabs for each system, but don't go more than a few sub-tabs if you wish to underneath those. It doesn't actually help. Table of contents should be very easy to read, and it should correlate readily between other detail that you include in the binder and the tabs, so that it's all in the right chronological and reading sequence. It's a good idea to include on your table of contents, in addition to the pages themselves, page numbering. That's a huge advantage both for the judge as well as for somebody creating the cost report or somebody else reading it, as you can easily go to a page number to identify what part you're talking about, rather than trying to find the part number located within a system. If you say it's page 99 and everybody goes to page 99 when you're presenting at the event, or even if we have a query for you at the event as well. So clear page numbering on every page and ensure that they are consistent across the binder and can be traced from system to system and back to the table of contents. The rules quite clearly say, international rules as well as our local addendum, stresses this over and over, but it seems people don't read it, and that is text size. It's got to be readable. It says a minimum size 10 font, and I've had pages in binders with about a 6 or 8 font, and yet the actual page isn't filled, and that is just very poor presentation. Just make sure you stick to a reasonable font size. If that means a few more pages, so be it. But just ensure that the font is readily readable for everybody, and you don't need a magnifying glass to do it. Ensure the legibility of the content too. If you just download the contrast sheets from the US website, it actually gives very poor contrast on some of the darker colors. It's a good idea, rather than just running with that standard background coloring, to actually go to a slightly lighter shade of background coloring. Stick with the color so it's traceable, but a lighter color gives much better contrast, and again, it is easier for the judges. But also, I would hope a lot of teams do this, is to actually have your cost report looked at and checked out by somebody who did not compile it. A member of the team will be very good fresh eyes on your cost report and how well it's presented and how clear it is. Any obvious mistakes are then located. And I'd really stress it's worth taking one of your guys a couple of hours and going through the cost report when you think it's ready, but before you actually submit it. That could save you a lot of heartache subsequently. And people may say, oh, why do we have to do that? Well, there's 100 points in cost, and getting your format right and avoiding some obvious mistakes is a very easy way to gain an extra 10 points for the competition, which may be much harder to get going a little faster on skid pad or endurance.
On top of that as well, and again, showing why the event is relevant to your time once you're in industry. Yeah, cost event is actually meant to get you ready for that. In industry, you do wind up having your work checked by colleagues to make sure that it is appropriate and that it actually meets the requirements before it actually gets submitted. So moving to the next section.
Next section, the soft copy. Again, soft copy comes in via Excel format. We only want one file. We don't want somebody submitting a whole pile of separate Excel files which don't cross-correlate to one another. This really makes it difficult if we're using the soft copy for checking and cross-referencing. If you don't have them all as part of one consolidated file. So please ensure that that is done and that you don't create a whole pile of separate files within that. The templates are all readily available from the web for that, of how to create those. So please just use them in that way. And secondly, there is the PDF format of the soft copy as well to be submitted. Again, good idea to get somebody to check those when they're sent in as well. Some years we've had an Excel format came in with a whole section missing out of it. PDF format had it in, but then it wasn't in the Excel format. Now again, that's something which could have easily been checked back by the team before they're submitted. So again, I'd stress that even with your soft copy, get somebody else in the team or fresh eyes to look at it before you do the actual submission of the cost report in both hard and soft copy.
I've actually seen one worse than that, David. I've actually managed to receive a cost report from a team, which was actually the previous year's cost report. So getting another set of eyes to look over the documents before they get sent our way will give you a world of relief. Like, you don't want to accidentally send the wrong document.
Right, if we go to the next section on your overall report, and again, this is basically re-summarising some of what we've said previously. In your overall report, you have your cover page, a table of contents, supplementary material as required, and as you may want to actually include, giving your part number system that you're using for it and how to read that. Any information you want to give about an overall view of how your vehicle was manufactured, what you might have done to help reduce the cost or make it more cost effective, include those there. Extra sheets like that can be very helpful in understanding your total cost report. Full bill of material, which is then included, which is downloaded from the website with the bill of material there, draft bill of material. You have every system within that, and within each of those systems then the separate breakdown into the assemblies and then the part underneath that assembly with full costings for each. All of those costings then should come back so that if I can look at the system cost, it's got to be a summary of all your assembly costs and readily traceable. Your assembly costs have got to be a summary of all your part costs and your separate listings of those. All your system breakdowns, as we're shown on the right-hand side, and again, these will be available, so I won't spend too much time on them. You come back and look at just what you need to follow. But clearly marked tabs, the bill of material for each system, the costing for each of those parts within that system must follow the bill of material structure, and your parts must flow up sensibly and logically into the parent assemblies. Any system supplementary material, again, should follow the BOM structure with each of the drawings identifiable back to the particular part number or page number and description within the cost report itself, so that the whole thing becomes logical. Rather than just throwing in a whole pile of stray part drawings, etc., at the end of a section with no cross-reference back to them, ensure you put a cross-reference back, and the page number is as good as any way of making sure that any drawing you put in or supplementary material can be traced back readily then to the parent assembly or parent part number for it.
All right.
Now, we found that the clarity of the cost reports can vary hugely between teams. It's not rocket science. Just break down each line item in the material, process, fastener, tooling sections as much as possible, and we'll cover this in more detail later in the presentation. But properly filling in usage or process description is very critical here in understanding and verifying what your costs are. If you don't list them in here correctly and clearly, you tend to make mistakes yourself in pulling the cost report together. And quite often we found mistakes coming back to this, whereas if somebody had written down exactly what they were doing, they wouldn't then have made a subsequent mistake in adding the lot together. Number the pages logically and clearly as we stressed before, and use that use column as much as you possibly can. It really helps to just understand what's in there. Doesn't have to be a great lengthy description, but just enough that an engineer reading it will know what the hell you're talking about.
Yeah, just to expand on that as well, it isn't even just for engineers. Like we mentioned at the start, cost event is here to prepare you for the real world. In the real world, if you do have to interact with somebody from accounting or possibly somebody within fabrication who will be looking at these sheets, they will be able to make heads or tails of what's actually being constructed through the use of that use column. So if you're able to basically pass on this as a baseline instruction to somebody who doesn't know what the part is, but they can still figure out what's going to happen, that's the ultimate goal of this.
Bill of material structure. again, this is a part which, when you get out into industry, and particularly if you're working with an automotive manufacturer, is very critical and is used in all of industry as the breakdown from your total vehicle or product level into the system level. It's then broken from systems into assembly levels and assembly down to part number level. In industry, you'd quite often find sub-assembly levels as well sometimes to help clarify the breakdown, where you just get far too many parts all listing going into one assembly. The Formula SAE and FSG bill of material assemblies do not go down to that level, so this is the format which you must follow. Follow that from your overall vehicle, your system level, down into each assembly, then the part numbers within each of those assemblies. Under each part number then, when you're developing your cost within that bill of material, you must make sure that you've got the material covered as appropriate, what processes are applicable, whether fasteners are required for them, and also process multipliers. Quite often we find mistakes here where people overlook using the correct process multipliers between mild steel versus aluminium versus stainless steel versus other materials. They must be used, and is one of the most commonly forgotten mistakes we find in there. And the other is your tooling as applicable for the part, where again there's a standard formulae laid out for how to cost the tooling and how many parts is to be written off over, with that cost then going into the total cost structure of the vehicle. The Appendix S3 does list where all of the systems go and what parts go within each system. There was previously huge confusion with electric vehicles, as the only published bill of material format was for an internal combustion car. And apart from that not making sense in terms of a lot of the powertrain descriptions, when we were receiving the cost reports, different teams would, because they weren't defined, would make their own guess as where to put them. So you found them all over the place and impossible to compare system costs between different teams. So we created the EV3 format, which is available on the SAE Australasia website, which defines how an electric vehicle cost breakdown or system breakdown is to be used to ensure everybody knows where to put the parts of an electric vehicle and they are consistent across all vehicles. And I think, yeah, go on to the next one. Provide the Appendix S3 gives you a good breakdown start for how the how your bill of material is put together. Your own parts, of course, within that, or your designs may vary somewhat within that. So you should use the basic assembly listings under each of those systems shown there, but the actual part numbers which go into each will obviously vary significantly from vehicle to vehicle. Now, we've got an assembly is bundled into one, another one which is costed elsewhere. Don't delete the line item from there if it logically fits there, but just use a descriptive note or a column or other notation there to just direct us to the new location for it, but don't suddenly delete something which really should be in that area, even if you have avoiding double counting cost. Then just put a simple note or clarification in there for it. Depending on what the actual design of your vehicle, If there is a logical reason for some minor variation away from this breakdown of assembly structures, then we will not be hard and fast and penalise you for an obvious engineering rationale for a slight variation to it. We don't want to see a wholesale non-compliance, but as I say, we will be slightly lenient if there's a logical reason for you to create something different due to the unique design of your own vehicle. Now here you've got on the next one here the breakdown of the, where are we now? Wrong way. Breakdown of the bill of materials structure only, where you have your suspension. Where you have your suspension, you have the assembly A0001, which is your bell cranks as an assembly part there. Then you have the description of it on the right-hand side. You then have the sub parts within that of a left-hand front bell crank, left-hand rear, right-hand front, right-hand rear, each with their own separate line item in there to build back up to them. From that, you will then obviously have within those rear bell cranks the actual manufacturing process relating to them, along with any other fasteners which may be required for them. The part numbering will be as you have selected, but should follow the general outline numbering sequence as described in the cost report formats available online for this. And if you are using anything different, you should have a very clear decoding of the part numbering system you've used at the start of your cost report. Now, the drawings and the other visual materials do provide the judges with a method of looking at the car overall. It does help a lot if we, in addition to just reading the process and the description and the cost, we can actually look at a drawing or photo or something like that for it. Rather than full engineering drawings, though, we don't want to be flooded with a drawing of every single part in the car. Rather, it is much better to use blow apart of assemblies, 2D third angle or first angle if you really prefer that, projection drawings, dimensioning the overall envelope space, key features of it. A 3D exploded view is one of the best things you can include with it, because you can summarize a whole lot of different parts on that, a logical sequence of how they go together, and just put in, if there's particularly unique parts with unique process operations on them, you may want to include an overview drawing of that. But again, don't get into just giving us separate drawings of every single shim, spacer, and washer in the vehicle. That's not necessarily, and it only clogs things up.
We don't need to reverse engineer your car. Don't stress about that.
Okay. And if you have photos, it's a good idea always to place a scale or a ruler in that photo, which then give a sense of scale of what we're actually looking at, and we can then cross-correlate that with the claimed dimensions of machining or whatever else is quoted in the cost report itself. Then have the templates for how your assembly cost is compiled, listing between the assembly with the parts going into that. Now, the assembly also, you have to include at an assembly level any processes which are required to put the parts into the assembly has got to be shown somewhere. And so you ensure that if you've got an assembly and it's got a whole lot of parts added to it, and you have not included that assembly labor or process in at the part level, then you've got to include it at the assembly level. And you should also include it in assembly level where the assembly is placed in the vehicle. There should be a process level which shows at the assembly where it goes into the vehicle. Quite often that is forgotten because people go through it at the part level and get all the processes right there, put them into the assembly, and then forget to put the assembly into the vehicle. Very common error we have found on that. So they're just a couple of sort of warnings or advice items on that one. The cost tables changed somewhat this year in the online from the SAE. The actual formats for the reports are still in the Excel format, so they're quite okay for those tables. But some of the previous tables, which were in the online Excel, have been put into online catalogues. They cannot be used readily to work in Excel from the prior Excel sheets into your own Excel sheets, as I know some universities had set up. However, the new cost catalogue format on the US website is strictly the 2017-2018 Excel sheets put into the new format. Therefore, if teams wish to use the previous 2017 and 2018 Excel materials tables to develop their own unique formatting into your own cost reports, it's quite okay to do that. The numbers in there the same. You would only need to just go on to the US website and check if there has been any update on a very new level of part, or a new part's just been introduced that you're using. Do check that as being on there. But the main use of cross-correlating Excel tables can still be done, but you'll have to use the 2018 download there. That will be available on the Formula SAE Australasia website, so that you can get access to that one in the old Excel format if you don't already have it available in your systems. There was a note sent out to all teams on this quite recently to cover this. Now, within those cost tables, and these are fairly straightforward, materials, they give you the list of all the purchased finished parts and the cost of raw materials as you may use in order to manufacture your own parts there. They're standardized within there, and bearings, all of this data is there for you to readily calculate what your own particular parts cost just by plugging in the correct dimensions as required on the spreadsheet. They're quite straightforward. The process tables also, they list the cost of the various operations. Again, here, one thing we have seen is if you are using 3D processing, then you must use the process cost associated with the correct material you are using for that. Again, a lot of mistakes we found in that one, particularly with 3D processing, that the incorrect processing costs have been used. So do make sure you've got the process cost for the correct materials there, and that you're not doing 3D and sintering metal and using the cost of building it up from polypropylene within there. Process multipliers mentioned before, straightforward. Just remember that you've got to use them there. The tables of all the fasteners are there, and again, they're readily traceable depending on standard sizes and plugging in just what are the dimensions of your parts. And the tooling, again, all of the types of tooling are listed and straightforward. Again, last year we found some people who failed to update and obviously use 2016 tables in 2017, where a number of the tooling required for some of the carbon fibre and other parts had changed, and that wasn't picked up by teams. So there were quite a few points lost by not doing that. So do ensure you're using the latest tooling costs. Now, again, I don't think we'll spend a lot of time on this there. We just listed what are your general categories that you can find within each of those listed there. We've got some examples there, but again, you can refer back to these. We won't waste time just talking about these simplistic things here. They'll be in this PowerPoint for you to look at subsequently on the website of what you actually will find available here. There, the cost tables on the fasteners. And that brings us to the end of that section.
The one thing that I'll quickly mention as well with a number of the fasteners is that many of them will actually be equation driven. So if you look up in the cost table, there'll be a fastener there. Oh, it doesn't have a cost next to it, must be free. No, there will typically be some sort of a number that you need to put in, whether it's a diameter, could be a length, whatever it might be. Put in that number, a cost will pop up. That is the cost that you actually need to copy into your cost report. So, yep. So diving into the next section that we've actually got here, it's about looking at things that you have potentially made or purchased for your car and the appropriate way of costing them within the cost report. So you'll typically find that the parts themselves within the cost table, they'll be organized by part type, the manufacturer, and then the model. So I actually do have the 20. Hang on a second. Actually, I need to change. Share desktop, share screen. So jumping into a cost report table, you actually do notice that materials will typically be organized by the material type. Then there'll be a particular type of the manufacturer of it. There will be the system to which it belongs and the cost and how it's actually coordinated, et cetera, et cetera. Now, the made parts, they can typically show up within the table as being made or student built. Now, those particular ones, whether you've actually purchased it or not, have to actually go through the process as if you had to build it from scratch. A perfect example of that is actually, I believe, a steering wheel. So, actually, while looking at it, steering wheel. One of the things that lists there is all have to actually be cost. And when you jump over to the comments, this should be cost as made, whether the team made it or bought it. And it states there, please have a look at section C3, currently S3.12 for more information. So yeah, any sort of unlisted parts that a student team has have to be made. Otherwise, an add item request is actually needed to actually make that part exist. Examples of made parts, they will typically start off as some sort of a raw material. You will then perform various processes on those particular parts to get it down to the size and shape required for the vehicle. Those parts might also require sub-assembly, so whether it's just fitting it onto something, fastening it. Examples of it include oil tanks, uprights, and A-arms. Purchase parts, so they're actually purchased in a ready-to-use state, so they can effectively be bolted straight into the system. They can be modified as the team requires for its vehicle, but they don't have to be. So examples of that are suspension dampers, ECUs, brake master cylinders. Now, we've got this little table which covers the rules required so that team actually follows the made versus bought requirements as stipulated for cost report. So you have a look at how the team actually acquired the part, whether the team has made it or whether the team has bought it. whether if the team has purchased that particular part, but the cost table lists the part as must be made, or it's not actually listed there, then you have to actually go through the process of making that part. If the table actually lists that part as a ready-made bought part, you are able to cost it as bought. On the flip side, if the team has actually manufactured something, it will either be listed as manufactured, or if the table lists it as a ready-made part, the made option is not in the table, so you cost it as bought. But if the made option is in the table, the team can actually choose whether they actually go through the process of having of going through step by step to make it, or whether they use the bought price. So
there's not a lot where there is the option available. No. There's very few where there is an option, and most of them are either have to be costed as made or bought, but some are available as student-made parts as an alternative to the bought part, but there's very, very few.
I think brake calipers is one of the few examples where students, for example, if they effectively reverse engineer a brake caliper from a manufacturer such as Brembo or Behringer, Willwood, and they manufacture it to that exact same specification, you then have the option of either using the one that has been, using the bought price there, or going through the process of what you actually did to actually make that particular part. Right, so this leads us to our next section, which if you do purchase an item but it doesn't exist, this is what the add item request why the add item request exists. So non-existent items in the tables that you'd like to see in the future can actually be added in. Now, the details are available at fsaonline.com, and you're also able to actually see past add item requests within the master table and committee decision. That said though, please do not submit add item requests directly to Formula SAE International, because they will typically be ignored.
Yeah, well, they'll send them back to us anyway.
Yes. So what typically, the fashion that we would like you to do, there is an Excel format AIR available on that website. Please download it, fill it out, and then this can get sent through to us here in the Australasian Formula SAE, and we will then deal with the international committee to make sure that that item can get processed, and then we will update accordingly based on those decisions. So with the actual sheet itself, don't forget to provide the details, information as to how it is purchased, material from which it's made. Yeah, go through that sheet and fill out the information appropriately. Again, the clearer that you make this, the easier it will be for us to be able to use the information to actually create the part for you. If you don't give us sufficient information, well, it's not our job to try and make this exist in the cost tables. It's your job to give us the information so that we're able to make it exist. So before we dive into the next question, was there any, next section, are there any questions about the cost tables and the templates? Nothing pressing? Hold now or forever hold your peace. Or speak now or forever hold your peace. Nope, not getting anything. Cool, so we'll jump into the actual case study. So we had a look at the AR. So with the ARM case study that we've got here, I want to give a bit of a shout out to Bill Riley, who was mentioned at the start of the presentation, because this is the example that he's actually created to kind of show how how a part can be costed. So looking at this particular part here, we've got the bearing cup that's at the very, very end. It holds the spherical bearing. We know that it's going to be manufactured from steel round bar, and all the processes need to actually be stepped. So it may start off as a round bar, as simply illustrated on the right-hand side. But rather than just diving straight from that through to the end, you need to go through various machining processes. You'd rough finish cut. You'd rough machine the inside and then do a finishing cut on that. and then you part material from the actual round bar itself. Now, it might be 1 millimeter from the outside, then ½ mil, then a parting cut of 3 millimeters down there, also not drawn to scale. And this is how it would actually turn out within a cost sheet. You'd have your material listed here, the steel alloy, and what it's actually getting used for. You'd actually list your processes there. So rough cut, then a finishing cut, face cut as well for the rough cut, then another finishing cut, again for the turning. Then you have assembly into the actual bore, adding in a retaining ring. Then the 2 fasteners that are getting used as well. You've got a spherical bearing as well, and the retaining ring that holds that spherical bearing in place. Any sort of tooling that might be required as well. Now, even with this particular part, if we actually have a look at it, there are still a couple of mistakes in there. So what I'll do is I'll get you to have a look, and in a few seconds, I'll start going through some of the things that have actually been missed. If you look at it, the first thing that shows up, there should be a steel multiplier in there. So that process should actually be 3 times more expensive, but that's not actually listed there. Additionally as well, we talked about parting the material from the bar. There's no parting operation between the lathe and the actual assembly. What's more, rather than just parting it, the bar will need to get put into the machine in the first place, and there's no machining, install, setup, remove cost actually listed there. So these are the kind of things that you might have actually created the part, but at the same time too, you're familiar with what's going on, and these are things that you might not notice. So being able to share your work with other people to potentially find these flaws, you're able to get them fixed up. So looking at the assembly layout for the actual part, we've got a bit of a sheet showing how it's actually been put together, and it's ready to get basically constructed. You'll have your various leg tubes, which are these ones here, part number 1 and 2. You'll have your tube inserts at each end, which actually are both machined and tapped, and which will wind up getting welded onto the tubes. You have your spherical bearing cup that we've just looked at. There's a sheet metal gusset that actually goes between the 2 tubes. You'll also have the spherical bearings and the rod ends at the very end as well. There's a little C-clip retaining ring. So there's a variety of parts that will be within this assembly, and these can't get missed out. So we've got a zoomed out version. We'll look a little bit closer step by step. But these are the kind of pieces that are required to make the A-arm exist. Again, those are all of the various elements that you'll need to do in order to make that, for example, the little threaded inserts, for them to actually be ready to get welded onto the actual arm. At the very, very end, it talks about the different welding operations that are required. And from this, we then get into something called welding fixtures. Now, welding fixtures is probably one of the most convoluted processes at the start, but it actually does make a lot of sense once you think about it. Now, in terms of actually jigging this up in order to actually weld it, you need to hold it in place. The welds happen. It then would get, in industry, you typically normalize it afterwards as required to make sure that everything isn't excessively stressed in the wrong areas. Now, to replicate this within the cost task, we try to do it in the simplest way possible, that there's a certain amount of times that you'd, for example, be able to use this jig to create A-arms in a production environment. And we call that a production volume factor. So there's 3,000 times that a jig might get used for a single type of component. And that particular jig will have what's called pickup points. So in this particular area, we've got 5. Pickup points themselves are the points where your jig is actually fixing or holding the actual component in place. We know that it's fastened at each of the bearing elements, so 1, 2, 3 there. And there's also 2 sections which are holding the tube in place. So you've got 5 sections, therefore 5 of your points will actually get, the quantity of welding fixtures required for this particular assembly is 5. Now, the unit cost itself, we actually get from the cost tables. If we jump to that and we go to our processes here, there will be welding. Where is tubing? Tubing, weld, round tubing. Oh, sorry, take that back. Tooling. There we go, that's better. So you'll have welds, welding fixture, $500 per point, and each point is a pickup or a support point. So that number there goes into and gets worked out to be 83 cents per AR worth of welding fixtures based on this particular jig layout. So that is effectively how raw materials through to a completed A-arm. So based on this sheet, the A-arm is completed, removed from the fixture, but not yet installed onto the vehicle. This is one thing that you also shouldn't be forgetting when you've actually manufactured your parts. Particular level will you begin to combine the single elements, your parts and your assemblies, into the final system. So you have to where you'll, for example, attach the A-arm to your uprights, where your if you've got if you're using bell cranks with this particular setup, making sure that your that your rod ends are connected appropriately to your bell cranks. If there's a pickup point on the chassis, to make sure that it's fastened to that appropriately. So these are the kind of things that you also need to make sure that they're fitted into some components. One of the things that we typically quiz students on is, for example, with the wheel and tire assembly. Are you able to show us within the cost report where you are actually putting the wheel onto the upright assembly and fastening it? So these are the kind of things. Make sure that you've got a completed car rather than just the parts required to make your car. So again, we've got our little inboard completed assembly and then the assembly report. So assembly, 1 kilogram line on line, inboard rod ends, power tool, inboard bolts to actually make sure that it gets fastened, and then a reaction tool to hold the nut as you're actually fastening the bolt. Even with this though, there's a bit of a mistake. Remember that we talked about getting somebody else to have a look at it. You know that you wouldn't attach a jam nut on straight away just using the power tool. You'd actually need to hand start it, fasten it as fast as you can, and then ratchet it on. Bearing cups and threaded insert require setup costs. And on top of that as well, if you wanted to manufacture something from a continuous feed, which is okay, you need to tell us that you've actually done it using a continuous feed system like a machining center. So include that as a note. If you've got a layout of how everything's actually getting machined up, feel free to include that as a little appendix as well. So just a couple of the review points. When you have a look at your assemblies, are all of the elements that you've used within it correct? Were any elements forgotten? What sort of assumptions have actually been made with regards to the part? And have you actually written these down to explain or back up your flow that you're actually using to manufacture the part or the assembly? And on top of that as well, can you supply any other information, so evidence, whether it's visual or otherwise, to complement your work? So whether it's an engineering drawing that can give us some information, a photo or a sketch. I know some teams have actually gone through photographing the actual manufacturing process and supplied that as a document. So finishing this off now, we're going into the things that you can expect come competition day, and I'll hand you back to David.
Okay. First item of this is the addenda, or addendum, or addenda in plural. For that to be taken into account, to pick up any changes, either added or reduced items, it's got to be presented at the time the team registers for the event. This is the only way we can keep a proper track of them and ensure they are all collected and delivered to the judges. don't just suddenly throw an addenda on the table at the time we come to judge your vehicle. That's too late. We want it actually submitted when you register for the event, so that by the time we come to do the vehicle judging, we actually have all of the addenda already in our possession.
Please do not forget this. We have, just to set a precedent, rejected probably about 40 or 50 sheets worth of changes simply because it got given to us at the actual judging time. And unfortunately, we don't enjoy doing this. Please don't put us in a position where we have to do it. Give the addenda at the time of registration, please.
Yeah, we may accept the addendum if it adds a huge amount of cost to your car.
I think you're being too nice, David.
Right. The next part is looking at the key considerations. Though, if there is an addendum, recognise that because you've made a change, and in industry and in business, it always costs you more whenever you make a change.
And you always save less if you actually
manage to save. Yeah, if you come and do it later. So quite rightfully, if you add items in an addendum, they're costed at 1.25 times the tabulated cost, and any items you remove from the cost report via an addendum, you will receive only 0.75% of the, or 0.75 of the cost, which is quoted in the table. Obviously, if you've removed a lot of parts, it's still worthwhile submitting an addendum, because you're still going to get the 75% of all those savings actually recorded for them.
And adding it at 1.25 times as well is also more effective than just ignoring it. One, because it makes it a lot more accurate, but two, because penalties are actually applied at 2 times, but we'll delve into that a little bit later.
Yeah. Okay. Now, the process on the day, which will generally take about 25 to 30 minutes. Firstly, we do a very quick check-in and introduction. We introduce the team and the car, which is done by a presenter from the team. We expect you to spend a little bit of time giving us an overview of the car and things which will be of interest to the cost judges. You may want to give us a summary of how you went about the total vehicle design, with the cost as a major factor you considered in there, any major trade-offs you may have made in developing your vehicle and deciding to maybe cost a bit more somewhere for the sake of performance, or alternatively to reduce cost because the performance advantage was not of good value. Cover how you went about designing it for ease of manufacture and assembly. Any techniques you may have used which are aimed at minimizing the cost and making your manufacture of the vehicle more efficient, particularly thinking here in terms that you're making production runs of maybe up to 1,000 vehicles a year, here in how you may have gone about doing that. Looking at the minimum constraint design and any other special actions which you may have taken and you think the judges may think are noteworthy, then bring those out. Next item is then 10 minutes where we will then discuss with you the cost report that you have submitted. We will generally have made a listing of any issues we have found with the cost report. We will also make a summary of good and bad features of the cost report to give you feedback on that at the event. And we will also, by the way, after the event, we'll have general summaries available of our commentary on your cost reports, which you can take away for or use. We generally publish them post the event, but so you have access to those to know what went right and what went wrong with your cost report.
Don't forget to pick them up as well. So many teams actually leave them at the end of the event and they wind up getting thrown away. Please don't forget to collect your cost report and the comments.
Yes, because they're going to be very useful to your next year's competition. But we also then look at the vehicle to make sure that the parts on the vehicle do correlate with the cost report. And this is where, of course, the need to submit an addendum if there's some obvious changes which have occurred here. We actually had to ping a team which might have otherwise won the overall event that year because they costed a fiberglass part and forgotten to put in an addendum to go to carbon fiber on a number of parts on the vehicle, which cost them quite dearly. The quality and the way you conduct yourself and respond to questions count. And again, be professional, but we expect people to be there to answer the questions who understand the vehicle. And when we ask a question, not to frantically start leafing through your cost report and then referring to your mates around you and saying, oh shit, does anybody know the answer to this one? On them. The people who are there presenting, and quite often it only needs 2 people, but they should be very au fait with the cost report and what it's made up of and ready to answer questions. Don't work off a different agenda versus the structure of your cost report. That's what you submitted. So if you're talking to the vehicle at the event, talk to it in the systems and format that you actually have in the cost report itself. And as I say, we will try to give you as much honest feedback as we possibly can to help you for future years. And the secret is know your cost report and your car well, and you're now justifying where you finished up to the panel. Again, as I said, avoid flicking between pages, and quite worthwhile doing a practice run with your group prior to the event, or even better, do the practice run with some people from outside your team who have not seen any of it. That'll get you a much better result.
Yeah.
Now, a little adaptation from Sun Tzu's Art of War there. If you know the tables and know your car, you'll do well in cost. If you know your car but not the tables, you may or may not do well. If you know neither, you'll do quite badly with it.
Yeah, and that was actually said, I'm pretty sure, or coined by Michael Royce, who was also mentioned at the start, and that is genuinely how it will actually go. We typically find that the teams that do especially well at costs are the ones who actually have the people who compiled the cost report there, and they're able to actually explain that without any issues whatsoever. So yeah, definitely strongly recommended to make sure that you are familiar with both the tables and your car and how everything has come about. So this leads us to penalties that if you don't know your car and if you don't know the tables, how will you get penalized? So,
okay, now there are report errors, but we have, when we mark your cost reports, we will mark based on clarity and any obvious mistakes or missing parts. We won't actually put those penalties into practice though until we have reviewed the car at the event, because A, you may have picked them up and submitted an addendum which covers these points, which therefore avoids these other penalties coming in, or there may be just some confusion which is clarified. There are 2 methods for calculating the penalties. These are listed in the rules: fixed point or adjusted cost. In general, we find because it's simpler to do with the amount of resources we have available, we will generally use the fixed point approach for most simple mistakes or errors rather than the adjusted cost penalty approach. At our event, and I'm not sure if all events do this, but where mistakes have been made, where costs are overestimated, we don't apply any additional penalty because the team's already penalised itself by inflating the cost of their vehicle beyond what it should have been at the event. We also give points or deduct points for the correlation between the cost report and the vehicle as presented. That approach may also be re-looked at when we do an overall evaluation, as we discuss amongst the judges at the end of the day, of how well there is a correlation between those. We do use discretion, however, when applying penalties. I don't think we are anywhere near as severe on application of penalties as some other competitions are. We think that it's, for the amount of work which goes in, we think it is just a bit over disappointing for teams to end up with 0 points due to just being penalised out of getting any points at all in certain parts of the event on the accuracy. So although we, in the fixed point penalties, these are the guidelines we use. Missing or inaccurate material, process, fasteners or tooling generally would incur 1 point for each of those occurrences. However, if there is within a system that a team has consistently missed one, where it's obviously just a bumbling error which occurs in a number of places, we may not apply 10 points for each place. If it's all within one system and a very consistent minor error, and again, depending on the level of it, we would not apply 10 points to that. We would probably apply only a few points for that. The same with a missing inaccurate part, 3 points each. Again, we would use some discretion here and may not apply the full 3 points in some cases, depending on how major and how significant is the cost which has been missed in there. And the same with the assemblies. Generally, though, if somebody's totally missed an assembly, then that's a fairly significant error. Yeah. And so we would rather, we would be more inclined to apply that for a total missing assembly. But as I say, we do use discretion to ensure that there is always compatibility between how we mark each vehicle, but we are not as deathly on this as some other competitions around the world may be for it. As we think teams still need to get something out of this for all the work which goes into it if you have done an honest job on putting your cost report together. Now, an adjusted cost penalty is the other method. This is used to add cost to the vehicle. As I say, we will generally use the fixed point penalty, but if the fixed point penalty wouldn't penalise teams enough for missing bigger items, or by not doing it, it totally distorts the relationship of your car to other cars and therefore alters points on other vehicles, we would do this. And a good example of this is where we had one team from some other country at one of our events had totally missed some huge parts of the car. But in fact, if you applied the points penalty only to that, they would have reduced their points down to 0 on accuracy for it, but they would have won the overall cost event for the points for lowest cost. Therefore, in that case, we applied the adjusted cost penalty to that, so that the team was then significantly inflated in cost to where it should have rightfully been, which therefore reset the points, and another team then got the 40 points for cost. So in cases like that is where we would use the cost adjustment penalty rather than the fixed point. But we will generally only use it where it is going to distort the points of other teams in there. Now, the real case scenario, and this is one where you really have a chance to make some good solid points. It's 20 points, and we will be putting out what the cost task is within the next month for that, but we're letting you get the actual cost report out of your hair first. It's where you are given a challenge to establish a better design or a lower cost design, or justifying cost approaches that are taken in a particular situation. That will be available on the website subsequently. Things to look at when you're doing that is to do, how would you rationalize cost? What is the right approach you would use in an engineering situation or a company? And use the same kind of tools of weighted trade-off tables to do there, functional tables, etc. Look at the effect on what your costs are doing to the overall design of the vehicle. Does it interact with other parts and assemblies? Does it change the performance of the vehicle? Is it a good value trade-off or not? Also, don't be misled in thinking you have to justify in this particular real case scenario the design or cost that's on your vehicle. Take it as a new assignment and develop the best cost approach and best presentation you can for this. And you may come up with recommending something quite different to what you have on your car, even though it's touching on some of the systems in your vehicle. Use realistic assumptions when you're doing this. And so again, it's well worthwhile for the 20 points. It's well worthwhile ensuring you spend the time on the real case scenario. So don't think it's discretionary low value. It's a very strong and important part of the event. And teams which have done a very good job on analysing the design on their vehicle and justifying their base vehicle and designs in that generally do a fairly good job also on the real case scenario for it. So again, be prepared to do a good presentation on that. It's handy to have, even if you are using a computer to present and show slides at the event for the real case scenario, it's always a good idea to have copies of those slides to hand to the judges and leave with them, because that enables, when the judges are comparing points at the end of the day and across teams, it enables us to get a feeling for what some other teams have done, where where the judges of one group of teams hasn't seen the other ones. Those handouts really do enable us to compare them much better.
Also looking at it from the point of view of engineering education as well, beyond Formula SAE, this is very relevant to what you will largely be doing in industry. You will typically find that your bosses will give you two tasks: to make something more effective or make something more economical. So with regards to the cost case scenario, you will have to justify your design decisions. You will have to justify the path that you actually want to take with regards to a possible development. So if you are able to justify the particular path that you're actually going to take, the critical thinking that led you to that path, you're a lot more likely to be successful with that particular endeavor. And this is largely what we want to pass on to the student engineers at Formula SAE, to all of the competitors who get involved. You're not there as sheep. You're not there just on a production line. You're engineers coming up with solutions. So being able to think your way through that process is critical to being an effective engineer. So please pay attention to this part, even if it's only, and I put that in quotation marks, if it's only 20 points of the 1,000 over the event, because it has a major effect to you as an engineer come your time to join industry. So this leads us to our final section, just the conclusion. We'll start off with the do's and don'ts, just summarizing what we have talked about over the course of this presentation. So do consider the legibility of your report. How are you presenting it? What are you actually, so like even down to the actual binder itself, have you considered that to make sure that you're doing whatever you can to make sure that the judges will have an easy job marking it? Have you actually used the published materials appropriately? Do you know them? So on top of that as well, make sure that you are breaking down every step as far as possible, or far as reasonably possible. Have you considered your BOM breakdown and how it cascades at each step? What about the supplementary materials? Have you included those to make sure that those marking are able to see what you've actually tried to present? And finally, do submit addenda on site at registration. Please don't wait until the actual event, because they won't get accepted. In terms of what to not do, don't lose track of submission deadlines because they sneak up on you. Don't use comb binders. Again, I'm going to stress that one. Do not oversimplify parts in an assembly, or do not oversimplify the steps within a part or an assembly breakdown. Don't just put down on a part that you did however many hundred cubic centimeters of machining. Tell us what the machining was for. Also, don't forget to use your process multipliers and your essential steps like machining, install, setup, remove, etc. So, and last but not least, do start early. Speaking as somebody who had to coordinate a cost report over 2014 and taught somebody to do it in 15, there is barely enough time for cost report if you start early. And if you don't, you'll typically notice that it is a mad rush to get it done towards the end. Please make sure that you're doing yourself a favor by making sure you do it on time. So thank you very much for your time and attention. We'll open it up, so you're welcome to unmute yourself. If you do have any questions, feel free to please send them now. So it does, okay, we've got a one person there. Right, so the one person who does have their hand up, what would you like to tell us? The Galaxy J5 Prime.
They're muted.
Yeah, unmute.
Yeah, he has to unmute himself.
Okay.
Galaxy J5, you're muted according to this.
And we can't seem to unmute you for whatever the reason. Okay. If you can't actually unmute yourself, feel free to post your question in the group chat.
Try the unmute all.
Yeah, that's going to be a bit messy, but
Yeah, I just see.
Okay, I think that's only actually
try again now, J5.
Hey, Fraser here from Wisma.
Yep. Go ahead, Fraser.
Oh, hey. I posted in the chat, but could you explain the fraction included multiplier on tooling costs a little bit, please?
The production volume factor, you mean?
No, so there's one more column to the right of that, which it's talking about in the rules is, I think, a fraction included multiplier.
All right, let's have a look at the rules. So fractional multiplier, which is unit costs. So we've got a sample
Oh, I go to the page, go to the bill of material table. I think that's what he's referring to.
Oh, is this what you're talking about here? Fraser? Yep.
No, so in a part down in tooling, there's an extra column that we kind of weren't sure about.
Yeah.
In the template for a part.
Is this the one where if it is used twice or 3 times on the vehicle, then you're on? In other words, if it's used for 2 or 3 different parts, that might be the one.
Okay. Okay. I think that may well be it. Just gonna have a look. Is it this guy here? Okay, here we go. So, fraction.
Fraction included?
Yes. So that's for let's go back to the presentation and go to hiding. Come back to the sample. Now you're talking about the one production volume factor and basically the column next to the production volume factor there, right?
Yeah, that's
tooling. Okay.
That would be if you have if your A-arm part has that tooling, but you had all of a sudden that same tool were applicable for your rear A-arm also would fit and
or your left and your right, or your left and your right.
Yeah, and your left and your right. So you would then have that tooling, and therefore it's available for left and right are using the common tooling. Then in fact the tooling would be have a factor of 0.5 there because it's used in for 2 separate parts in there.
Okay, cool. Yeah, that's what we thought it probably was, but just wanted some clarification. Thank you.
No problems. Any other questions that we might have at the moment?
Yeah, so when putting assemblies in, if we've got identical parts that appear in lots of different assemblies, would we call the part every time, or would we create the part within each assembly that it appears in?
You'd actually I'd recommend doing it once and then just calling it back.
Yeah.
So like there's no point reinventing the wheel, and that's typically how it goes.
Yes, we've had this quite a few times before, and in fact, as a judge, I prefer it done once, but then the part accurately listed, but you then have just a cross-reference to that to derive the source of where that cost has come from, but you don't need to repeat the detailed tables over and over again on it.
Yeah, what you'll actually notice is that having a clear part numbering system will help a lot with this. So for example, we, in the example with the A-arm, we had the threaded inserts at the end of the rod. Say for example, you're using a subframe that gets split apart so that you can fit the engine in back and out. And yes, this is exactly how we had the curtain car back in 2012. If we were using a similar threaded insert at those particular points, and it initially showed up in the A-arms, we'd actually list that with the full assembly link and then part number. That's how we actually created our part numbers. And then we'd refer to that full complete part number when we're creating the assembly for, say, later on in the chassis. So as long as it's accurately and appropriately referenced and we can actually find it, that makes life that much easier for us. That's probably the critical thing, that clarity. Do we have any further questions? Is anybody else hoping to find out something new? And again, don't restrict it to just an element of what we've covered tonight. If there's something else with regards to cost report that maybe hasn't been covered with the depth that you'd hope, feel free to ask this too.
Yeah, or if subsequent to this, if you do have any other cost report related queries, then submit them to the Formula SAE site as just as a clarification question. We've already had a couple of cost report questions coming in, and we're quite happy to answer those and send out a clarification to you if you happen to think of anything else subsequent to this presentation.
Yeah, so
who should we send those queries to? Sorry.
Send them to, it was, we listed earlier, Formula SAE at saea.com.au.
Okay, thank you.
It's listed earlier in the presentation. It's the same one you send basically your rules queries into as well.
Sure.
So it will be to this address in here. Yeah.
Sorry, we've got another couple of questions if you don't mind.
Yeah, fire away. Go for it. Yeah.
So, with like a ratchet or a wrench process, we're just wondering what the size in that is defining. So there's a less than 25.4, less than.
Yeah, correct. So that is the diameter. Yep, that is. This is the diameter. So you'll have a process here, and you are referring to, I'm guessing, for argument's sake, fasteners, power tool equal to or equal to or less than 25.4 millimeters. Now that 25.4 millimeters is a reference to the diameter of the fastener getting used.
Not the thread length, which is
not the
listed
thread
elsewhere.
length. So that's the diameter there.
Sorry, could you repeat that? It just cut out for a moment.
Okay, so the 25.4 in this particular case, we're focusing on this one here. So power tool equal to or less than 25.4 millimeters. That is a reference to the diameter of, or the working diameter of the fastener being used. So for argument's sake, if you have a M6 bolt, your active, working diameter is going to be 6 millimeters. So you would use this one here equal to or less than 6.35 millimeters. But if you're using M8, because it's greater, you'd use the one above.
Okay, cool. Thank you. With setup changes, how frequently or what scenarios would you use them for?
So say for argument's sake that you have a, you're machining an upright and you're machining it out of billet. Now you've machined the one particular face and put in the holes, taken out material, but you actually need to machine the underside to actually, and we're assuming that you're using, say, a 4-axis machining center. So you'd have to, at that point, open up the machining center, remove the part, flip it around, and re-secure it. Now, that would actually be a machine setup, machining setup change. So the machining install setup remove is effectively putting the material into a particular tool or a device used to to go through some processes to make the final part, and then take it out. If you're doing it in a single operation, great. But if it turns out that you perform one operation and then you have to modify the actual placement of that element to continue the machining, that is when you will use the setup change.
Okay, cool. Thank you very much. So you wouldn't use setup change as detailed as like changing tools on a lathe or anything?
That actually is. For argument, okay, so if you have a, okay, we'll talk about a metal lathe, manual metal lathe, and you've actually, you're using a regular facing, for argument's sake, facing bit, and you've faced off a part, you've done the rest of the machining, and then you have to part it, and you're using a different part for that, but it's not actually installed on the lathe. yes, that actually requires a machining setup change. So
because your part you're working on remains the same, but you actually have to change the tool over.
Yeah.
So it's a change within it, but it's not a total resetting up of the part into the lathe.
And again, it boils down to a lot of how you'll have it set up. For example, if you do have a machining center with turrets in there, it's feasible to assume that you would actually have all of your appropriate tools and all your appropriate bits on that turret. If you're using, you can actually have, I think it's 4. Most machine lathes will actually have some. I think it's a 4-point turret on there. So yeah, set up your things and yeah, literally go through that process of what's required to actually turn it from raw material into the part, and yeah, plan it out. You'll probably have some sort of a workflow sheet to kind of give you an idea of how it's manufactured, and yeah, draw off of that to actually come up with your list.
Thank you very much.
No problems. Any further questions?
One was around metal spinning. We just couldn't really figure out how we would do that.
Wheel spinning.
Yeah.
We're talking about the process that's required to create wheel shells.
Correct.
When you look at the material table, could you find wheels listed there as a student made? The answer is no. That's why there's nothing for wheel spinning, because wheels are all assumed to be made.
Yeah, there's like carbon fiber shells.
Yeah. Sorry. Yes. Yeah. That's not spinning. That the only student made wheel is for a carbon fiber student made wheel. There is nothing in the tables for a student made. Now, students this is a good example of where the students can make the wheels themselves, but the cost which must be used is the cost of the closest equivalent bought wheel for that. So that if you made your own wheels, which are effectively a 10-inch 3-piece wheel, then the lowest cost you can claim is the Kaiser cost of $57.50 a unit for those, even though you've made them yourselves. And in fact, I thought in our addendum we actually highlighted this point about the wheels not being a student-made item.
Yes, because there were in the
past, we've had this quite a few times that this come up, and we've just had to immediately dub the team for submitting that and apply a higher cost to them. I mean, some of them came in with $5 wheels because they claimed they'd made them themselves. They got hit with the higher cost and also a penalty for ignoring the instructions in the rules.
Does that answer your question with regards to the wheel shells?
Yes, it does. Thank you.
Excellent. Do we have any further inquiries?
Yes.
Yes.
Hi, Miguel from Monash. I've got a question regarding the rapid prototyping and whether we need a machine setup for that. I understand that rapid prototype doesn't need any fixtures or anything.
Correct. So you don't need the fixtures, but at the same time, too, like in a rapid prototyping, so we'll think, say, sintered 3D metal printing. you'd still need to, for argument's sake, load the program onto the actual machine to actually install it. You would need to put in your metal powder. You'd probably need to do a bit of a check of the machine. And when you actually remove the part out of it, you'd need to probably brush off any sort of material, maybe wash it off a little bit. So when you think about it, yes, you do actually need that process. Another example, a lot of people, I actually remember asking this, I think in my first year, as a bit of a question to see what students thought. Is laser cutting a machining process? So a lot of them basically tried to say that it's not a machining process, so therefore you don't need the machining setup install cost. But at the same time too, if you send off a part to a laser cutter or to a water jet cutting supplier, they will need to place the material on the actual bed. They will need to secure it down. They'll need to load up the program. They'll need to nest all the parts. So there is some human-machine interaction. That's the best way to look at it. Do you need to interact with the machine in order to get a finished part at the end of it? And if so, then you do need that machining process.
Awesome. Thanks very much.
No problems. Just trying to see. Okay, addendum. Where's the addendum hiding? Okay, local addendum. Here we go. So just quickly jumping back to the inquiry about the wheel shells. I believe. Wheels. First buy. Within the cost table, there is no entity for team-made wheel rims or shells fabricated from metal. Accordingly, to ensure rational cost data, if wheel rims are team-made, the reported cost must be at least equal to or greater than the lowest cost bought rim or total single wheel if single piece of equivalent type or design to the team-made pieces. This clause does not apply to student-made wheel centers. So that's just a clarification for that one. Right, any further questions that teams may have?
No.
So
No.
would you do a machining setup then for like hand drilling or for drilling?
No. Hand drilling, you're actually not, unless, well, no, I wouldn't. I don't think that you actually need to do that.
Well, I suppose it would depend a little bit on, are you doing the hand drilling as a basically a production line thing where you're going to do 1,000 of them, then you probably would want to set them up for doing that. But just
But at the same time too, you
I mean, normally you wouldn't use
at that point.
Yeah, I mean, normally you would not use a hand drill.
You only hand drill if it's in situ, in which case, you don't need it.
And even then, for the accuracy of what you're doing, I mean, you would normally never use it for manufacturing a thing accurately. A hand drilling something like that.
Okay, so a bench drill you would set up.
A what?
Like a bench drill.
Yes.
A bench drill would require setup. Hand drilling, no.
Okay, thank you.
Any further questions?
Yeah, I'm Maxie from University of Auckland.
How you doing, Maxine?
Yeah, good, thanks. With the cost report, when you're, say, doing like machining, would you need us to include the calculations, or would you just need a like total amount?
I'm going to leave this as a relatively open answer. You need to provide us with information that will give it in the clearest way possible. So if calculations are the clearest way that you're able to present it, do that. If you can present us with, I guess you could say, step-by-step photos showing how you came about with that particular, those particular numbers, then I would say do that. At the same time as well, if we see that a block of billet has been turned into a lot of swarf and a very exotic looking part that you use some sort of topological optimization to achieve, then yeah, we'll raise a question if it looks like you haven't taken out enough material. But yeah, be prepared to back up the numbers that you have generated. If including those costs can save you some grief and it's not going to cost you too much time to generate those numbers, I say do it.
Okay, cool.
Yeah, in general, traceability is the key here. So that whatever cost you quote should be traceable by the judge to see that it is rational and reasonably accurate. And we have had cases, or in fact it's very common to find that you'll get a machining cost quoted, something done from billet. There's no dimensions shown of what size billet it was that it's machined down from. So you've got no idea as to the accuracy of that machine cost. There are the in the tables, the boxes to put that in, so they should be used to help trace through in terms of how the machining costs are actually derived there. So yeah, just think about it. If I gave this to somebody else, can they find out where I got this number from? If you can, that's fine. If not, then you need to put more information in.
Okay, thanks.
No problems. Any further questions that teams may have?
Okay, well, look, we hope this has been useful to you doing this. It is our intention that this has been recorded, including your Q&A, and this is going to be made available for future use as well. Plus, the PowerPoint will be available on the website, so you can refer back to the actual tables in the slides in here later on, so you can come back and look at that again. And as I say, any other queries which may come out as you think about this a bit more, then you can submit them to Formula SAE as a cost inquiry, and we will try and get back to you as soon as we can with responses on that. So depending on what time of day it is, wherever you are in the world, then thanks very much for all attending, and we'll say either good night, good morning, or go and have our dinners.
No dramas. The other thing I also wanted to quickly mention as well, and I'm saying this as a former competitor, for many of you, this might be your very, very first time in a relatively senior role looking after cost event related issues. And hats off to you. All of you are probably getting thrown in at the deep end to a certain extent. I know exactly what that feels like. It might not be the best experience first time round, but yeah, you're taking the steps required to be able to put your best foot forward come competition day. So hats off to you. Well done for taking these steps. And yeah, we're looking forward to working together with you at competition, and looking forward to seeing the next generation of engineers that are going to be, yeah, creating waves throughout the world. Well done. And if that basically covers it, I guess, thank you very much. And we'll draw this to a close now. Thank you.